Dear student, today we will do the section B of May-June 2023 Unit 1 paper. So already we did its multiple choice in our first session. In this session today we will do the section B question. I will try my best to explain the questions in an easy way, which is according to the Edexcel requirement. Question number 19. This question is about the mass spectrometry and the shapes of molecules. In a mass spectrometer, vaporized atoms are ionized and the ions formed are accelerated, deflected, and detected. State how atoms are ionized in the mass spectrometer. Now, this is the most important question and it comes again and again. Here, they already mentioned that the atoms are vaporized, but how they turn into ions in the first chamber, which is called ionization chamber. So, the gaseous atoms are bombarded by a beam of high energy electrons which knock out one electron from each atom and turn them into positive ions. I will mention here the key points according to the mass scheme of the Edexcel specification. So here a beam of high energy electrons. This is one of the key points. And the second point is like knock out one electron from each atom. Now, the next question is state how the ions forms are accelerated. So after the ionization chamber, the ions are accelerated in the accelerator, but actually what is used, these ions are accelerated by in the electric field. So the ions are passed through the electric field and they are accelerated. This electric field is the key point. So you must focus on this point. In this question, explain why isotopes of an element have the same chemical reactions and their ions are deflected differently in a mass spectrometer. Dear students, read each and every part of the question carefully and focus that they mean to the student to answer which part. So they are asking that isotopes of the elements have same chemical reactions, one part, and the ions are deflected differently in the mass spectrum. Chemical reactions of any atom depends on the number of electrons. Chemical reactions of any atom depends on the number of electrons or electronic configuration or the number of electrons in the outer shells. So isotopes have same electronic configuration. So have same properties, same chemical properties. This is the first point. And for the second mark, their ions are deflected differently in a mass spectrometer. Now, the deflection of the ions in the mass spectrometer depends on the mass of ion and charge of ions. Now, here we will just focus on the first vector because we expect that all isotopes, when turned to positive ions, they have +1 charge. So the charge is same. So we will say that deflection of ions in magnetic field depends on the mass of ion heavier the isotope will be deflected the least. You can also write down that the isotopes having less mass will deflect it the most. So this is for the 2 marks for this question. Now, this one, like data from the mass spectra, may be used to determine the relative atomic masses of elements. State what is meant by relative atomic mass. Again and again, this question comes, repeated question. So I will suggest the students to learn this properly and memorize it. The exact definition is the weighted average mass of all isotopes of atoms of an element. This is 1 mark. This is the first section. Now we are defining the relative atomic mass. So compare with the mass of one atom of carbon 12. So this is the second part. So the first part, the weighted average mass of all isotopes of atoms of an element compared with the mass of one atom of carbon 12. In this section, we are going to calculate the relative atomic mass. Again, it's the easy question, but the direction which is given in the question that we have to calculate the answer in 4 significant figures, and they give 4 in bold, so you must comply this. Now, to calculate the relative atomic mass, this is the abundance percentage, and this is the mass number. For the second isotope, this is the abundance percentage, and that is the mass number. So we can calculate 35 times 75.53, then plus 37, the mass number of the second isotope, times its abundance percentage, and now the sum of the percentage abundance, that is 100. You will get the answer 35.4894. But to meet this situation, we will round it to 2 decimal places, so it will be rounded to 49. Now this is more than 5. So we will increase this by, this is more than 5, so we will increase 8 to 9. So this is 2 decimal places, or it contains 4 significant figures. It's an easy question. Now, the mass spectrum of phosphorus trichloride is shown. Phosphorus has only one isotope, that is P31. Now, the x-axis represent M by ZR charge to mass ratio, and this is the relative abundance. Number of peaks you can see in the graph. There are 3 peaks in the region of M by Z 101 to 105. Now this is 80. Then this is from 80 to 120. So this all is divided into 40 sections. So this is 90. This is 100. This is 110. This is 120. Now they mean these peaks, these 3 peaks, that it's in the range of 101 to 105. Now let's come to the question. Complete the table to show the ions responsible for these peaks. Now, you have to work out this question. First of all, you will find the ion which mass is equal to 101. So let's see here, phosphorus must be there as its mass is 31. There is only one isotope. Chlorine has 2 isotopes, 35 and 37. So here, if we just calculate 35 and again 35, with positive charge. Don't forget this charge because we are supposed to write the ions, formula for the ion. So this is PCl2, in which phosphorus is 31 and each chlorine is 35. If you add 35 plus 35, 70 plus 31, so 101, and it carries positive charge. The next one, it's this easier now. Why? It is only 2 more than 101. So again, for this one, it's a bit easier. Phosphorus is 31, one chlorine is 35, and the other chlorine is 2 more, that is 37, with positive charge. So its mass will be 103. And the last one is 2 more than that. So phosphorus 31, chlorine 37, and chlorine 37. With positive charge, I told you that don't forget the positive charge. Otherwise, you will lose the mark because we are writing the formula for the positive ions. In the next section, show that the relative peak heights given in the table are consistent with the isotopic ratio of 35, including 37 being 3:1. If you look at here, chlorine ratio is 35 and 37. This is 3:1. Means if total chlorine atoms are 4, so 3 will be 35 and 1 will be 37. Now for the 35, there are 3 atoms out of 4, while chlorine 37 is 1 out of 4. This you must know at the back. So here we just write the ion. One carries 101, one carry 102, and the other carry 103, sorry, and the third one carry 105. Now, if you look at for this one, phosphorus 31, chlorine 35, and the second one, chlorine 35, with positive charge. This is the first ion we wrote in the table at the previous page. So look at here, this and this chlorine 35, chlorine 35. Now, the abundance is 3/4. The probability of chlorine 35 is 3 3s are 9/16. For the second ion, this is phosphorus is 31, chlorine is 35, the other chlorine is 37. Here, chlorine 35, its probability is 3/4, while chlorine 37, it is 1/4. But here we will take both probabilities like that. Again, phosphorus 31, now chlorine 37 with chlorine 35. So this is 1/4 times 3/4. So we will get here 3/16 plus 3/16. So the total will be 6/16. Now, for the last ion, phosphorus 31, chlorine 37, chlorine 37. So this is 1/4 times 1/4. Both probabilities will take for both isotope, and we will get 1/16. So for this one is 9/16. For this one is 6/16, and for this one is 1/16. So see here, just to remove it from fraction, if we multiply each by 16, so we will get 9:6:1. And this is the ratio given in the heights of these isotopes. Part D1, draw a dot and cross diagram of a PCl3 molecule. Show outer electrons only. Phosphorus belong to group 5. Total is 15, 2, 8, and 5. So it's very simple to draw the covalent bond. You must know that both are non-metals. So covalent bond structure should be drawn. So 1, 2, 3, 4. Now we have fifth electron, so this will be pair. Chlorine are 3, and each chlorine, they are group 7, so they have 7 electrons. So 1, 2, 3, 4, 5, 6, 7. It's another one. So 1, 2, 3, 4, 5, 6, 7. And this is the third one. 1, 2, 3, 4, 5, 6, 7. So you will get the dot and cross model. Please don't do mistake in drawing the dot and cross model. First of all, you have to decide that the compound which is given is either covalent molecule or ionic compound, or there is dative covalent bond. They definitely give some blank. Here they give you molecule, so be sure it is covalent. So never go for the ionic. Now, in this case, explain the shape of a PCl3 molecule. If you look at here, in this case, I just display this again. Shapes of the molecule is decided by the central atom. The central atom in this case is phosphorus, which is bonded to 3 chlorine atoms. Now, how you'll write for 3 marks? So you see here, NPCl3, the central atom, which is phosphorus, no need of this, no problem, has 3 bond pairs and 1 lone pair. This will carry 1 mark. Because you mentioned that the central atom phosphorus has how many bond pairs and how many lone pairs. According to electron pair repulsion theory, the repulsion between lone pair and bond pair is greater than bond pair and bond pair repulsion. So definitely the lone pair will repel. The lone pair repel the bond pair more to get maximum distance. And minimum repulsion. The shape is trigonal planar. Now, some students, they do write here the bond angle also, but it is not demanded in the question. So if you write this answer 3 points correct, you will get 3 marks. But if a student writes and he is 100% sure about the bond angle, so should write that the bond angle is 107 degree. But suppose in this case, if you are not sure and you write the wrong bond angle, so maybe they will deduct your mark. The answer will be fitted to here, but actually I display this diagram, which is already displayed in your paper in the previous question. So then it will be fit into the space. Now, the next question is question 20, part A, barium chloride can be prepared by the reaction of barium carbonate with hydrochloric acid. Equation is given to you. They are asking write the ionic equation for this reaction. To write the ionic equation in a shortcut, you will only focus or you will only write down the reactants or products which are given, which are present in pure solid, liquid, and gas state. It means you will ignore the aqueous solution. You are not supposed to write the aqueous compounds. Okay. Now, when this is the first point, you will write only those reactants and products which are in gaseous state, liquid state, and solid state. Then the second point you must keep in mind, you will balance the element, balance each element or each atom by writing its aqueous ions on opposite side. This is just the points which you'll keep in mind for other question. Now let's come to the question now. Barium carbonate is solid. Then carbon dioxide is gas on the product side and water is pure liquid. As I told you that the solid, liquid and gas. So the products we write on the product side and the reactants we write on the reactant side. We ignore this. Why? They are aqueous compound. My dear students, again, to write an ionic equation, only write down the gaseous, liquid, and the solid reactants and products. Now you will balance the elements by writing their aqueous ion on the opposite side. How come? Like here, barium is present. This side there is no barium, so you will balance this barium by writing its aqueous ion on the opposite side. Barium belongs to group 2. So this is okay. If you look at like carbon is 1, oxygen is 3. So this is 2 and 1, 3. Now we are not having hydrogen. Hydrogen is present on this side. To write hydrogen on this side must be an aqueous ion. So there are 2 HCl, so they must be 2, and you will easily get the ionic equation. So these are the points which I give for your other question practice. But in this question, how to write the ionic equation, this is one of the shortest and easy way. Write down only solid, write down the reactant or product which are in solid, gas, or liquid state, and then balance them by writing their aqueous ions on the opposite side. In the next question, they are asking to calculate the atom economy by mass of this reaction, of this preparation of barium chloride. Atom economy, you must know the formula. So atom economy, the formula is given mass of the desired product. And it is very simple because in the wording of the question, you will easily get that which one is desired product. For the preparation of barium chloride, so that is our desired product, and divide by mass of all products and times 100. I am sure that most of the students will be aware of this formula. Now, atom economy percentage, so we can atom economy, we can get it now by writing the mass of the desired product, barium chloride. So barium is 137.3 and chlorine is 35.5. So you will write 137.3 plus 2 times 35.5. Then divide by, again, this because this is the product, pure product. So if you look at here in the equation, barium chloride we wrote, now mass of the all products, so barium chloride will come again. So let's see here, again 137.3 plus 2 times 35.5. This is 1 plus 12 plus 16 times 2. This is carbon dioxide product. And the last one is 2 plus 16, which is for water. So when you calculate this, you will get 208.3 divided by 270.3 times 100. And your answer will be 77.1%. This is a simple question. You can easily score these 2 marks by writing the formula and putting the values in it. Now, in this question, barium chloride has a melting temperature of 962 degrees Celsius. Cesium chloride has a melting temperature of 646 degrees Celsius. Explain by considering the ions involved, the difference between the melting temperature of these period 6 chlorides. Now, one is barium chloride and the other one is cesium chloride. If you look at here, so lithium, sodium, potassium, rubidium, and cesium. And here, beryllium, magnesium, calcium, strontium, and barium. So this cesium and barium, they take it. So cesium will give cesium chloride and barium will give barium chloride. Both are ionic compound. This is +1 -1 and this is +2 -1. Now, dear students, when such question come in comparison, so you will just take this and this. Now, chlorine is common. So no need to discuss chlorine. You will only and only focus on cesium and barium. Why? Because in both compound, the main point of difference is cesium and barium. So let's start to the answer. So you can easily say they're asking barium chloride, BaCl2, its melting temperature is higher, while cesium chloride is lower. So you can, when you compare these, so it is very obvious, you will see it that barium charge is +2 while cesium is +1. So you can say that barium ion has more charge than cesium. Second one, barium ion has smaller ionic radius or ionic size than cesium ion. Due to greater charge and due to smaller ionic size, the electrostatic force of attraction between barium and chloride ions will be stronger than the attraction between cesium and chloride ions. So as the attraction between barium and chloride is stronger, so it needs the fourth mark, large amount of energy to break the bond. And that's why its melting point is greater than cesium chloride. In part 4, you see that they gave a table and electronegativity values are mentioned against 3 different elements. Covalent and ionic bonding are the extremes of a continuum of bonding type. Explain the difference in bonding between barium chloride and beryllium chloride using the electronegativity values shown. In this case, although they did not explain this point or they did not give this point in the Edexcel Pearson student book or specification, the electronegativity difference, but it's a rough idea. If the electronegativity difference between the two bonded atom is, now here the difference is 1.5, like me 3 minus 1.5, so 1.5. It is less than 1.7. In some books, it is given 1.7. In some books, it is given 2.1. But 1.7 is the most agreed value. So the bond will be covalent. And here, barium chloride, the barium value is 0.9, while this is 1.5. So, sorry, this is 3. So the difference is 2.1, which is greater than 1.7, and the bond will be ionic. But like to write this question, you will just say that the difference of electronegativity between barium and chlorine is greater. So the bond is ionic. While the difference of electronegativity between beryllium and chlorine is low, so it is covalent. It's a common point. Look at here, like beryllium, magnesium, calcium, barium, sorry, strontium and barium, and then radium. down the group, ionization energy is decreasing. Your answer is enough here. Because you just mentioned the electronegativity difference, you are strict to the answer. So barium chloride is ionic, while beryllium chloride is covalent. But see here, like beryllium is here, it is very difficult to remove electron from beryllium. So it is difficult for beryllium to form ion, while barium is almost near the bottom. So it needs very less energy to remove 1 and 2 electrons. So it will easily form barium ion. So that's why this is also one of the idea that barium chloride will give ionic compound, while beryllium chloride will prefer sharing of electron. But whenever you're writing the answer, there are many ways, but you have to stick to the table. Why? They give the electronegativity values. Dear student, in this section, barium chloride reacts with group 1 sulfate M2SO4. Now the equation is given to us. This M2SO4, which is group 1 sulfate, react with barium chloride. We get barium sulfate and group 1 chloride. This group 1 sulfate mass is given 7.98 gram. While when excess of this is added, so the mass of the barium sulfate precipitate produced after drying in it is 10.72. So two compound or two values are given. One is the mass of this and one is the mass of this. These are the given values. Now, what is the question? The question is, we have to calculate the mass, we have to calculate that this group 1 element is which one. Definitely, we will start from the known value. So this is the more accurate value, more accurate in the sense, more known value. Why? We know the barium sulfate MR. We don't know M, so that's why we cannot use this right now. But we can get, first of all, you will find out the barium sulfate moles, which is equal to mass over MR. Mass is given to us 10.72 divided by the barium sulfate MR, which is 233.4. So the number of moles we will get is 0.04593 moles of barium sulfate. Okay. Now look at here in the question. The relationship are the link between the mole. This is 1 mole and 1 mole. If barium sulfate is produced 1 mole, so this is also 1 mole. But barium sulfate produced is how much? 0.04593 moles. So if this is M2SO4 and that is barium SO4. So if this is 0.04593, so this will be sure the same 0.04593 moles. Now, this is one part. The second section, we get the number of moles of M2SO4 as well. Now, in the next section, you can say part 3, 0.04593 moles of this M2SO4, its mass is equal to this 7.98 gram. So what will be the mass of 1 mole? So you can easily calculate that X is equal to 7.98 divided by 0.04593, and your answer will be 173.74 gram. There is the third section. Now the fourth one. You can write in the different colors so you can get easy idea. This is the MR now of 1 mole of M2SO4. Now the M2SO4 mass is 173.74 gram. Now we know the SO4 mass. So the mass of the SO4 is, this is 32 and this is 64. Yes. So all combined together, we can get 96.1. So when you subtract the mass, you will get 77.64. But this is the mass of M2. Let me, these are two elements. So what will be the mass for single M? So this you can divide by 2 and you will get 38.8, which is close to 39. So the element is potassium. So first we find out the number of moles of barium sulfate, which is being produced here, 1 mark. The second point, from this calculation of the moles of barium sulfate, we come to the number of moles of the M2SO4. This is second point. The third point is from this mole is equal to this mass. So what will be the molar mass of one? We found that 173.74 gram. In the last section, if the mass of M2SO4 is 173.74, we are already like clear about the SO4 mass. So when you subtract the mass of SO4 from M2SO4, we get the mass of M2, 77.64. We need the mass of M, so this divided by 2, you get 38.8, which is almost 39, and it's the mass of potassium. So by this way, you will score 4 marks. Now, in the next question, question 21, it is about, again, the topic 3, bonding. You can see in the first look that they give graphite. Graphite has hexagonal layers and which are placed one above each other. They slide over each other. So for this reason, they are used as a lubricant. Now let's come to the question. Graphite electrodes, electrolysis. Graphite electrodes are used in the extraction of aluminium by electrolysis, yes, of aluminium oxide. This aluminium oxide, it is dissolved in a molten cryolite because it is insoluble in water, and to melt it, it needs very high temperature. Still, even we want to dissolve this in molten cryolite, but it needs high temperature, that is 950 degrees centigrade. Now let's come to the question. They just gave you the STEM question. In this part, they gave you the info that aluminium oxide is dissolved in molten cryolite at this temperature. And the second thing is graphite is used as electrodes. These two things, two informations are given. Explain how the structure and bonding of in graphite make it suitable for this application. Now we will link graphite, why it is used as an electrode and how it can work at this high temperature. So these 2 points are here on which you will focus and you will explain your answer. Refer to the diagram in your answer. Yes, you must have to refer to the diagram, otherwise you will easily lose 1 mark. We have to explain now why graphite is good conductor of electricity, 1 point, and how it can withstand at this high temperature because it's high melting point. But these 2 points we will explain in the structure and bonding of graphite is given in the diagram. So let me move the question a bit up to produce the space for it. The first thing, graphite, this is like an easy part. Graphite has a giant lattice structure and exist as hexagonal layers by strong covalent bonds between carbon atoms. To break these large number of strong covalent bond, large amount of energy is required. Large amount of energy is required. So it has high melting point. So this will be the first part. Now, if you look at the structure, the second part now, in hexagonal layers, each carbon atom is bonded with 3 other atoms. So they contain one delocalized electron which can move atom to atom, or which can move. This is also enough. So it is a good conductor and it can be used as an electrode. Again, this is calculation part, and this carries again 4 marks. Now, the half equation for the electrolysis reactions are shown: negative electrode and positive electrode. It means anode and cathode. If you look at here, the number of electrons lost is equal to the number of electron gain. To write the overall equation, this is aluminum and this is oxide. And we get 2 aluminum plus 1 and 1.5 or 1.5 oxygen. So the ratio between the aluminum and the oxygen is 2 to 1.5. Now, the question is, this oxygen which is produced here, it reacts with the graphite electrode and produce carbon dioxide gas. What is the question? Calculate the maximum volume in dm cube of carbon dioxide measured at RTP room temperature and pressure, which could be produced when 1 kilogram aluminum is extracted using this process. Molar volume of a gas is given, which is 24 dm cube at RTP. So they give us aluminum. The given data is aluminum 1 kilogram is extracted. We will see first now that with this 1 kilogram aluminum, how much oxygen we can produce. And this oxygen then will produce the carbon dioxide, and what will be the volume of this carbon dioxide. So let's come to the question. As I told you, that the ratio between the aluminum and the oxygen is it was 2 and it was 1.5. Okay. But we will start with this 1 kilogram aluminum or 1000. So 1000 gram. So the number of moles of aluminum, again, mass over mR. So this is 1000 gram divided by 27. And we will get the moles 37.04 moles. Now look at here. If we have 2 moles aluminum, we have 1.5 moles of oxygen. So if we have 37.04 of aluminum, so how much oxygen we can receive like? So 37.04 times 1.5 divided by 2, and we will get the number of moles of oxygen 27.78. So this is the amount of oxygen we will get if we produce 1 kilogram of aluminum. Now, we will come now to the second question like this part. In this part, carbon react with oxygen and we get carbon dioxide. Now, this is the amount of oxygen. So this is 27.78 moles. No need to calculate. The reason is this is 1 mole, this is 1. So it means the number of moles of oxygen equal to the number of moles of carbon dioxide. So we will get here 27.78 moles of carbon dioxide. This is the second part now. In the last section, we will change this into volume. And we can easily change into volume as the molar volume is given. So volume is equal to 27.78 times the molar volume as the reaction has been carried out at room temperature and pressure. So when we multiply this, so we will get 666.67 kg. And this is the final answer. So first we change this one, the number of moles of aluminum, which is being extracted, like number of moles, 1000 gram. This is given in kilogram, change into gram, because mass over mR, mass must be in gram. Divided by the atomic mass, you can say the atomic mass or the AR, mR, better write air, okay. 37.04 moles of aluminum has been extracted. Now, this is the second section now. Let's come here to this ratio. 2 moles aluminum, we will receive 1.5 moles oxygen. So 37.04, we will receive how much? And this is the answer for that. Now, the third question, the third part, Let carbon react with oxygen, we get carbon dioxide. So they are in the ratio of 1:1. So if 27.78 mole oxygen, so it will produce 27.78 moles of carbon dioxide. And the last section, fourth section, we have to change this into volume. And multiplying by molar volume, we can easily get the total volume of carbon dioxide produced during this process. So 4 steps and 4 marks. Now, in this question, every year in the United Kingdom, about 7.2 billion aluminum cans are recycled. Suggest 3 ways. And in this recycling reduces energy consumption. Only you will focus on the energy consumption, how it reduces it. The recycling. And this 3 points, they are asking 3 ways and 3 marks. So number 1, as we know, in the extraction of aluminum, we carry out electrolysis. So electrolysis needs less energy. Sorry, electrolysis needs more energy. Than recycling. So this is very clear because we need electricity, which is a part of energy. We need high temperature to dissolve that in the cryolite. The second point, energy is required to extract, like by heating and other stuff, and transport the raw material, which is bauxite. Now, in this recycling process, in recycling, we need to melt aluminium only, which needs less energy than electrolysis. So this also reduce the consumption of energy. 3 points and for 3 marks. Now, this question is from the organic crude oil. Question 22. Crude oil is mainly a mixture of saturated hydrocarbon that can be separated by fractional distillation. The diagram shows in a simplified form the products of fractional distillation. These are the fractions which we receive after fractional distillation. State what is meant by saturated hydrocarbon. The IG's level questions, but you will focus on 2 parts. One is saturated, one is hydrocarbon. So compounds contain hydrogen and carbon only. And contains only carbon-carbon single bond. So the first part is for the hydrocarbon and the second part is for the saturated. So this is the part A1 in question number 22. Part 2, describe how the fractions in crude oils are separated during fractional distillation. So in this case, the crude oil is strongly heated to vaporize it. First point. Second, the fractions with lowest boiling point reaches to the top, and the higher boiling point fractions stay near the bottom. of the column. They are condensed and separated out. Part B, again, this is calculation part. And this time it carries 5 marks, so you have to focus more. This question is based on the ideal gas equation. Butane, this one, is found in refinery gases. It is present in the top fraction of the crude oil. It is used as a propellant in pharmaceutical inhalers. An inhaler that provides a total of 120 doses contains 1.55 gram of butane. Calculate the volume in cm3. Now just focus on each and every part, please. A propellant used for each dose. Used for each dose. At this temperature and this pressure. Use the ideal gas equation and give your answer to an appropriate number of significant figures. In this question, I already underlined the points which you need to focus. So in this case, you will start, but as you know, let me move this a bit up to make more space over here. Now, first of all, you see the temperature is given in degrees Celsius. You have to change this into Kelvin. This one. Pressure is given 100 kilopascal. So you will write 100 times 1000 Pascal because this kilo, so means 1000. In the ideal gas equation, temperature is always in Kelvin, pressure in Pascal, and volume must be in meter cube. So when you calculate the volume here, it will be in meter cube. So we have to change into centimeter cube because it is the requirement of the question. Now let's come to the question. We have to calculate the volume of this butane, which is used in one dose. For 120 doses, this is the mass. So see here, you will start from here. Like if this is butane and this is the number of doses. So for 120 doses, the butane mass is 1.55 gram. So for one dose, how much mass will be needed? So X is equal to 1.55 times 1 divided by 120. So X is equal to, we will get the mass of this, and this is 0.01292 gram. Okay. Now, the second section, we will change this into moles because butane is a gas and we will use here the number of moles. So again, this formula is coming mass for MR. So 0.01292 divided by the butane MR. And the butane MR is, this is C4H10. C4H10. So this is 48. So 58. So divide by 58. And we will get the number of moles of butane, that is 0.000223 and moles. This is second part now. Now let's come to the third part. And the third part is the equation. So PV is equal to nRT. We will calculate the volume. So nRT over P. To put the values, volume is equal to number of moles is 0.000223 times R is the ideal gas constant, general gas constant. The value is given 8.31 times temperature is 298 and divide by this one 100 times 1000. So you can do like this also. So when you calculate this, you will get the answer 5.51 times 10 raised to the power minus 6. As I told you, whenever we use this formula, the volume will be calculated in meter cube. But we have to change into cm cube. So the last step is this 5.51 times 10 raised to the power minus 6 cm meter cube divide by 1 million, not divide, multiply by 1 million, because we are changing the m actually. We are changing the bigger to smaller. So we will get 5.51 cm cube, and this is the final answer. So see here, by using this information, first we find out that one dose contains how much butane, then we change into its mole, dividing by mr of butane. This mole we need to put here in this formula. R is given, temperature is given, we just change into Kelvin, pressure is given, we just change into Pascal. We calculated the volume in meter cube, and by multiplying with the 1 million, we change into cm. This question is solid question, carried 5 marks. So much weightage in the paper. Part C, octane is found in the gasoline fraction of the crude oil. Write an equation for the complete combustion. Now, this is given complete combustion of octane. Complete combustion when oxygen is in excess, but that is not that much important. Complete combustion always produce carbon dioxide and water. This every student must know. That what are the products of complete combustion? So look at here, octane C8H18 and in the excess of oxygen. And the product will be carbon dioxide and water. 1 mark. To get the second mark, you have to balance it. Carbon is 8, so make it 8. Hydrogen is 18, so make it 18. Now, oxygen is 8 times 2, 16, plus 9 times 1, 9. So this is 25. So you can write here 25 over 2. Or if you are confused with this, so you can say that 25 over 2 means 12.5. Plus 12.5 times 2, so you'll get 25. And this is the balance equation. But the third point now, they wrote here include the state symbol. This is octane. Octane is in which state? Liquid. It's a part of petrol. Carbon 1 to carbon 4 are gases. Carbon 5 to carbon 17 are liquids. And carbon 18 onwards are solid. These are about alkane. So this is liquid, oxygen is gas, carbon dioxide is gas, and water is always liquid. So now this is complete 2 marks, okay? Now give 2 reasons why alternative fuels such as bioethanol are being developed to replace those produced from the crude oil. This is very simple question. Like bioethanol is made from the plants. So you can say that crude oil is non-renewable, is it will run out. Crude oil is a fossil fuel, and all kinds of fossil fuels will run out because they are non-renewable. They cannot be renewed again and again. Okay. Second point, like crude oil causes global warming. Is they give more carbon dioxide, while bioethanol is carbon neutral. So it is safe for the environment as well. Why it is carbon neutral? Because as it releases the carbon dioxide gas that was absorbed by the plant during photosynthesis. So the amount of carbon dioxide absorbed by the plant during photosynthesis is equal to the amount of carbon dioxide when the bioethanol is made from their plant and is combusted in the cars or in the factories and the vehicles. Straight chain alkane, such as octane, are converted into the branched chain alkane to improve the performance of the petrol in the car. Then the conversion the process. Now the process in which the straight chain alkanes are converted into the branched chain alkanes or the cyclic alkane is called reforming. Given equation using skeletal formulae for the conversion of octane into 2,5-dimethylhexane. State symbols are not required. So see here, first of all, you will draw the skeletal formula. So 1, 2, 3, 4, 5, 6, this is 7, this is 8. Now it will change into 2,5-dimethylhexane. You will start from hexane. So 1, 2, 3, 4, 5, and 6. Now this is 1, this is 2. So one methyl group is attached at second position. This is 3, this is 4, and this is 5, and one attached at 5 position. That's it. And it will be 2,5-dimethylhexane. So this is the reforming, the straight chain alkane change into the branch chain alkane. In part D, in steam cracking, a mixture of hydrocarbons and steam, this, right, focus, at 850 degrees centigrade is heated out for a very short time in the absence of oxygen. Give reason why oxygen should be excluded during steam cracking. Keep in mind, we never ever use oxygen in the cracking process directly with hydrocarbon. Why? It will then combust the given hydrocarbon. So to prevent combustion of hydrocarbons, an easy question. So if there is no carbon dioxide, there is no oxygen, so there is no combustion, and the hydrocarbon will be cracked. Ethene is the major product. State one use of ethene. Ethene can be changed into, it is used in the preparation of ethanol. Much more ethanol is produced by ethene and reacting with steam in the phosphoric acid and 300 degrees Celsius temperature and a bit pressure. Or you can also write ethene, so it can be used in making polyethylene, which is a polymer plastic bags. Easy option. Okay. The last question is regarding ethene react with hydrogen bromide to form bromoethane. Draw the mechanism for this reaction. So this is very solid marks. Please listen it carefully. And I will suggest that just increase the size of the font. See here, my dear. This is HBr. Bromine is been more electronegative. You will always start the arrow from the here they give the question, draw the mechanism for this reaction, including curly arrows and relevant lone pairs and dipoles. You have to strictly stick to the question. So the first point, you must start from the middle, this, and you will draw full arrow. This is considered full arrow. This hydrogen will get partial positive charge, and this bromine, as it is attracting electron, partial negative charge. Why? It electronegativity. This is one mark. Now, from the pi electron of the double bond, this from the middle, you will attack here on the hydrogen atom, which is positive charge. Now, when these two attacks done, so you will get the next step. This one hydrogen, you are free to attach to any carbon. We attach to the left side carbon. This carbon will get full plus charge. Curly arrows, already we put it two curly arrows. The relevant lone pairs and dipoles. Dipoles are this one, partial positive, partial negative. And bromine will carry negative charge and lazim one lone pair. So this is a lone pair. Conditions we are qualifying. Now the last step is this will attack on this, but never ever go from the negative to positive. Always a lone pair of electron will attack on this positive charge. And the next step or the last step product will be CH3, CH2, and Br. And we get bromoethane. So these 3 marks, please, again, from the center of this bond, If will not come from the center, so you will not get the mark. You will lose mark. But the ace level marking a bit strict from the center of this double bond, not from here, not from here. Otherwise, you will lose again the marks, and you will always drop to the partial positive charge. When you write this, here you can attach hydrogen into any atom. Now this is negative charge, this is full positive charge because it lost its electron, and you will bring an arrow from the lone pair to the positive charge and you will get the final product. So I think this was the last part. I'm not wrong. Yes. So to dear student, I tried to explain the questions in a bit easy way. Inshallah, in the coming sessions, I will try to explain question paper of the 2024 and then 2025. Take care and please subscribe the channel.